Okay. I think we should get started, even though it's like daylight savings and, some of you are probably still in bed. It's dark and all. We can get started whenever you guys are ready. Elijah, you feeling cold?
Yeah, kind of.
Oh, wow. Wow. Are you at Foothill or at home?
I'm at home.
Wow. Okay. Yeah. Well, it's rainy, but out here it's not that cold today. Anyway. Well, you know what? Today, I think we can start working on. We'll continue working on pointers, heap memory. Oh, I remember. We were planning to implement a stack. Yeah, it'll probably take 10 minutes. We've done a lot more sophisticated stuff than implementing a stack. So this stack should be fine. But after we finish a stack, what we can do is we'll try some interesting linked list problems, okay? So some problems that you can use linked lists. Well, there's some problems that involve linked lists. And I think not in the quests, it'll be interesting to do. So we can absolutely do that. Next week, which I believe is the last, this is week 10. So next week is the last week of classes. So we're not allowed to have classes in week 12. So next week is the last week of classes. And I believe that, next week is also finals week at UCSC. Yeah, okay. And I think also UCSB and many of the UCs. So last week of classes, but we'll try and keep, we'll do, I am still thinking of that Wheel of Fortune game. Maybe we can do that. We did it last quarter using a slightly different kind of animation, but today, this quarter, next week, we'll try and do this using that screen animation we got, so that we actually have a a nice picture of. We'll try. I don't know. I'm just noodling the idea off the top of my head here. By the way, important message is that some of you are enrolled in my CS2D, yes, for next quarter. Unfortunately, it seems that it is very likely that section may be canceled because there are not enough people in it. So, it doesn't make sense for Foothill. I don't know why it doesn't make sense because, well, I don't know, maybe there's some break-even point, given government subsidies and all. Doesn't make sense for Foothill to run a class with under 20 students on the date of the census. So if you guys manage to convince some of your classmates or other people to enroll in CS2B, there's a good chance it'll run next quarter. Otherwise, you may be forced to enroll in a different 2B by someone else. They won't have, I don't think they have questing. I don't think anybody else is running questing. Nobody's asked me for it anyway. So I think you'll do a traditional section of 2B if this gets canceled. It's a pity because, I think the 2B prepares the students to do 2C. And many students who get into my 2C having done a less challenging version of 2B, mainly meaning, there are lots of classes where you can enroll in the class. You don't really have to understand the material. Assignments, you can just look at someone else's assignment and make some changes here and there. Try and get an overall high-level understanding of the assignment. Oh, well, binary search, just chop it up and do this thing. Up, down, all right, like that. And you explain it in a hand-wavy way. That kind of passes. Even, surprisingly enough, even if the math proof gets flagged, I know of math teachers who get the student to say, oh, how did this work? Can you explain the proof? And then, they explain it in a hand-wavy way, no evidence at all that they actually did the proof. And the teacher says, yeah, okay, all right. So, and so that doesn't help the student at all. But in computer science also, it's more prone to that kind of a problem because, you know, you can just look at someone else's solution and say, well, this is how binary search works. I know how binary search works, and submit it. And, and chances are a lenient professor might actually just pass it, and you may pass that, but it does not do anything to the learning of binary search, because as you know, even a child can understand binary search if you explain it at a high level. Yeah, so anybody can understand binary search. So, but the reason professionals are in demand, or real computer scientists, who learn these things are in demand, or because they know how to do the little detail of it. Because the details is the devil is in the detail, right? The detail is where you actually prove that you really understand binary search, not just a child's explanation, right? And so that is where the implementation comes into the picture. So I don't know what the value is of doing an easy course in computer science where you can just, look at a solution and say, well, I have a smattering of an understanding, I pass this class. Yeah, doesn't do any good, because you'll forget this class after a while. And you probably have to do a bigger struggle elsewhere where you have to encounter binary search as a part of a bigger solution. And it's always when you're working on bigger projects, eventually you'll be in teams where you'll be working on bigger projects, and people will be in your team will be trying to understand the big picture and saying, well, because understanding the big picture is also hard. And so, the product manager or the CEO says this is what needs to get done, and these are the nitty-gritty, and this is how we control for these little things, and how attention to detail is as important in the big picture as in the small picture. However, what I've found is that people who somehow sneak in, squeak into the big teams somehow, pass an interview at a big company by hook or crook, or squeak in when they're when they're in a team with working on a big project, and people are talking about big ideas. These people are also trying to understand the thing, understand what the big picture is. But before they understand the big picture, they find themselves having to understand lots of the little bolts, nuts and detail that they should have understood already before going into the room and talking with the big boys and girls, right? So doing the big algorithm out there. They're trying to understand it, but they can't make any sense of what's going on in that room, because they're still trying to say, well, in order for me to understand that, I need to understand how binary search works, or I need to understand this works. But that should have happened already back in college. That didn't happen, and so, but that the panic of not understanding something basic when you're in a room where people are talking about higher level stuff is a really, really bad panic. Think about butterflies in your stomach. That is nothing compared to the panic that you'll have in a big team, in a big group, where you say, I managed to get into this company, where everybody is a rock star, everybody doing great stuff, but now they're talking about stuff that I have no idea what they're talking about, and I have to understand some basic stuff before I even begin to understand what they're doing. Is absolutely no fun. Because I know people who are sweating, when they're in a room like that. They're physically sweating, and they're at a loss to answer questions, and you ask them. So that is no fun at all. Okay, you won't have that problem when you're trying to understand binary. So right now, when you're doing these little things, it'll be challenging and you're frustrating, but that frustration is like 1/10 or 1/100 of what you'll feel if the person just squeaks past and says, okay, well, I don't want to face this frustration now. I'll just squeak past and I'll learn things on the fly, on the job, right? When I get a job somehow. But those people are setting themselves up for extreme unhappiness later on. Because you'll face a lot of self-doubt, saying, well, what, these guys are obviously better than, have more knowledge than me because they are able to talk about these things, and I don't have the knowledge to talk about these things, okay? And and nobody wants to be in that position as far as I can tell. So please tell your classmates, not classmates, anyone else you think might benefit from my section of 2B to enroll in it, so that the class doesn't get canceled and it'll run on schedule. And it'll be fun, right? You can talk to my current 2B students. They're actually having a lot of fun. Some of them are working on extra credit projects and fun stuff. And they're all recorded on YouTube too, so you can take a look at them. So I think it is important for people to do in community college, any college you go to, right? It's important for them to pick the most challenging classes first, and then when they feel that they've got enough challenging classes to keep them completely occupied and say, I can't do anymore, then they still have units to fill. They should pick easy classes for the, for the units they have to fill. And so the danger is saying, I'm going to get all the challenging courses. I'm going to do only the challenging courses because I don't want anyone to think that I am a person that takes less than challenging stuff. That is a recipe for failure because you won't be able to do well in any of them, I think. Unless you are, proven already, you've done this lots of times in the past and say, well, I have the ability to do that because I've already prepared myself. I have the training to do all these things. Then you can go and pick all the challenging courses and do it. But the danger is when people don't have the training to handle the challenging stuff and they just say, I want to do it. That is not conducive to success. Okay, all right. So today, how about anyone can pick up the code screen and code. And what we can do is try, right off the bat, we'll just implement a stack with pointers. It's not a big deal. I think we should be able to get it done in 15 and 20 minutes. And then after that's done, we have question and answers. Anybody can ask any question about the stacks. Before we get into that, obviously, you can ask me any question you have about, past material that we've covered, or also, questions about the final law. You can save it for next class. Next week even. But anything that we've done so far that is still confusing. I gotta check, if you guys are in other classes, okay? If you guys are in other classes, not just mine, okay? Now, obviously you must be in other classes. Maybe this is not the only class you're doing. Has the attendance basically dropped to like this level in your other classes? Have people just stopped coming to other classes also? Are you down to like 3 or 4 students? Right now it's like 7 students, right? 7 students, 9 students, 6 plus 2, 8 students in this class. Has it dropped to like 8 students in your other classes? What is the issue? Why are students not attending class when it is so important, especially in computer science, to attend class, and watch coding happen in front of your eyes and participate in coding? This is also like super duper important. Why are students not attending class? So I want to know that, because then I can fix that in next quarter, if possible. There's no point in just making lectures mandatory and saying, well, if you don't attend lectures, you're going to fail. It doesn't really help because, students will say, well, I'll just take a fail and do something else next quarter, right? So we got to come up with a good solution for this. I only have like a few quarters more to try this out, because then after that I'll be retired, and so I won't be following up on these things anymore. But I'm still interested to know, why is it that students drop off? This is interesting stuff. We're doing interesting stuff. We're doing really valuable stuff that is you will find useful yourself later on. Why? And you've paid money for it. And there are people here willing to teach you, your classmates, me, your tutor. So many people are here, and still people are being absent. Why is that? I don't know. Are your other classes also? I know in Pali, that's not the case, right? In Pali, attendance is compulsory, and you get marked for tardy also, right? When my kids went to Pali, they were, they had 2, the attendance register had 2 columns, one for tardy and one for absent. And so even if you were late, you get marked for tardy in Pali. So, so I know, Pali keeps up the attendance records through to the end of the year. But so some of you in colleges or at Foothill, I don't know why students are just missing in class. That shouldn't be the case, right? Have you noticed this in other classes at Foothill? Not about Pali, okay? In other classes at Foothill, or other courses you're doing, maybe not at Foothill, but college level courses, has attendance been dropping off towards the end of the quarter? Yes? Well, Namrata is nodding her head.
Yeah, I think it's like a combination of like burnout, because like people are working so hard for so long, and like it's like near the end, and it's like it's hard to, like, we know that all students doing all these classes and like they're all hard at the end. I think it's harder for people to like manage that and also keep up with all the stuff at the end, because everything's hard and all the assignments are important and hard. But yeah, I like for this class, attendance does matter and like really counts. So like I'm not really sure like for this class in particular, but like I would, if I had to guess, that's the combo of factors that I'd say is playing a role.
I see. Would you say, Namrata, you would say that is pretty much the same at UCSC also?
Yeah. Also the classes like that I'm taking, they have like recorded, this also class has recorded versions. So like usually people will just like not come and then like watch it later on. And like,
oh, so maybe we should stop recording these classes, you know, and say, but you know, I see. But yeah, it's a combination, like that factor also, and like Erica said, it's people enrolling in too many hard courses. I think that is the problem, you know, and they have too many things to do in week 11 and 10. So that's maybe it's a systemic issue, and maybe it's just a, you know, cultural issue in this area in Silicon Valley, where everybody says I got to do AP courses or I got to do honors courses in everything I do, right? Even stuff that I'm not going to major in for the rest of my life, I'm going to do an AP here, and so I need to have a you know, honors literature. You know, honors literature, even at Foothill, honors literature and all, if you do honors English, it's not an easy task, because honors English means that you got to be reading for 6 to 7 hours every week. So you'll get a fat book and you got to understand like 5 chapters this week, right? Reading for this week is 5 chapters. And you got to read it, and then there'll be discussion, and then you got to write about, you know, oh, this is where Hemingway says that sentence made by Hemingway is not a random sentence. That was a sentence chosen by Hemingway after like 2 weeks of thought, maybe, because that's what it means, right? Or, you know, Robert Frost poem, right? Everybody says this is what it means, but actually, you know, I thought about that, and it means completely, you know, it's something exactly the opposite of what people are saying. So those kinds of things that take a lot of time. And so, but people say, well, I want to do you know, honors English and this. So why? Because when you're majoring in computer science, you know, write a computer science paper, you don't have to write computer science research papers using, you know, using, you know, very low likelihood dictionary words, you know, huge vocabulary and things like that, you know, fancy rhetoric and things like that, that they belong in English, not in computer science. So there's no reason why you need to get an A+ in rhetoric when you need to do computer science or a math paper, a STEM anyway. So yeah, so certainly that is something to watch out for. Maybe I'll say that, you know, maybe I'll say that to Foothill at some point. Anyway, you know, the reason why we have low success rates, low attendance towards the end of the quarter, all of these things is just because students are just overloading themselves. And it's not just, you know, and it's just not a hypothesis, okay? So many of you have actually told me, sent me emails saying, I'm doing so many hard courses that I can't devote enough time for this. People are sending me email all the time. That is not an excuse at all for doing badly in a course. It's like, oh, I'm doing badly, so give me an A because I'm doing a lot of other hard courses. Yeah, well, you get an A in all those other hard courses, not in this one, because you're not doing enough in this course, right? So that is not an excuse, but people use that as an excuse, saying, well, you know, I'm doing hard courses, so I should get some slack in here. No, that is not an excuse. Right. So anyway, when you guys are ready, any of you should feel free to pick up the screen, and we'll just go to online. I'm just so surprised that we went to online. We used online GDB all the way through this quarter, right? Even last quarter, we figured that as we got to week 6 and 7, we said, you know, online GDB is not cutting it anymore. We'll just do VS Code or Xcodes because we need to produce an executable, run it and all. But this quarter, so far, we've done everything in online GDB. That is really cool. So any of you, whoever wants, including Hannah, right? Even though you coded last class, anybody, the first person to grab the screen can have it, and we can code from there. We'll probably have, you know, multiple people coding today, you know, because tax is quite easy to code. And I bet, you know, here, let me do that Price is Right thing. We're going to code stack, the stack ADT in less than 50 lines, okay? 50 lines of code. And also each line is not like a Python long line, okay? Each line, just reasonable code like we've always been writing. I think a stack can be implemented in less than 50 lines. 40 lines, let's say 40 lines, okay? 40 lines of code. And after that, someone else can pick up the code screen, and then another person can have a go. And we'll try and implement a linked list problem. It's a common problem, okay? Linked list. All right, so we'll try and do this, okay? So you have a linked list which with numbers in ascending order. So you may have 1, the next node may be 7, 15, 47, 200, and so on. So all the numbers are in ascending order. You got one more like that, right? So you have another one says 2, 27, and so on. So two lists that are both in ascending order. And then let's say we set ourselves the task of creating a third list, which is a union of the two, right? So you've got to merge the two, but it's still got to be in sorted order. So you can't just merge the two, stick one at the end of the other. It's not in sorted order anymore. So you got to merge the two and they got to be sorted. So we can try and do that. After that, that's also very simple, by the way. Okay, that is also very simple. But I think that together, the two of them, two of those tasks are sufficient to take up the whole of today's class. Enough instructive material in both those classes to get familiar with pointer manipulation and linked lists. Okay, so anyone who wants to code today can just pick up the screen and start coding. Okay, and Matt, Sabrina, and Karthik, you should also feel free to switch on your cameras at the earliest. Great, great. Okay. All right. So who wants to code? Sabrina, are you here?
Right. Yes, I'm here. I just can't turn my video on today because I'm at work.
Sure.
So
all right. Yeah, all right. No worries, no worries. You can just talk from time to time, and that's fine. Yeah. Okay. So, but who wants to code? Maybe Sabrina can code because she's not sharing a screen. Sabrina, do you want to code today?
Not really.
Okay. All right. No, that's okay. That's okay. Don't worry about it. Okay. Who else? Who else? So Namrata. Okay. Great. Okay. So yeah, pick up the screen, and then we'll go to online GDB and create our basic template. You know, hash include. Put a comment on the top. Delete everything. Put a comment on the top saying today's class code. Today, we will finally, for sure, definitely, 100%, definitely implement a stack, okay? Because every time we say, we're going to do it, and we never did it, okay? For sure. Say for sure at the end, okay? Oh, did it auto-complete stack? When you said stack, it automatically put the thing in? Yeah. Okay. All right, okay. So, yeah, hash includes. Excellent. All right, great. Okay. So, and by the way, I really like the movie that Sabrina produced. Well, it's Google Slides, but I just recorded it into a, turned that into a YouTube movie. So thank you, not Sabrina, Namrata. Very nice movie on the link list. Okay. Yeah. Oh, it is the 14th already. All right. 14th, Ides of March or something. All right, so let's go to line 6 and hit enter. And say we want to create a class, and let's say the class is called a stack, all right? We'll just call it stack. But we'll call it stack of integers, okay? Stack int. You can call it either stack int or int stack, call it stack int or int stack, up to you. Okay, stack int. All right, great, excellent. All right, now what we'll do here in the stack int is yeah, okay. So this is something called an inner class. We're going to do an inner class. There's no magic, nothing to an inner class. It's just a class that's being declared inside instead of outside. Okay, so this is what we'll do. So inside here on line 9, just say class node. Okay, class node. Yeah. And then in here inside, yeah, you want to say int data, and then enter, and then class node space star stack, node space star, node space star next. So every quarter, people do have this confusion saying, well, I have node star next or node space star next, okay? Or int star p or int space star p. So my recommendation is always attach the star to the variable, not the data type. Okay, if you attach it to the data type, it sends a wrong message to the person reading your program saying that this is a data type for node star. So this means that everything that on the right is a node pointer. No, that's not the case at all. That's not the way the compiler sees it. The compiler sees that, you know, star node is a node, which means node is a pointer to a star, that thing is a node P is a pointer to a node, not right. So and next, next, and I think next is fine. Next, all right, semicolon. All right, so that's basically it because it's a struct. So and also tag both data and next as public, right? So inside the node class, just say public for both of them. Okay. Now an indent in the two. Right now here, why? So this is two. Public got indented by 2 spaces, and this got indented by 4. Make that 2 spaces, not 4 spaces. 2. Okay. All right. So now a public class with everything public is usually it's not used because it exposes everything in the class. However, we are doing this for instructional purposes. Okay, so and 2 reasons. Okay, 2 reasons. One is instructional because we just want to know how a stack works. The other reason is because it is an inner class. It belongs inside of stack. Okay, so that means you don't have to. You can just treat it as a structure. So what we'll do now is comment out. Well, because if we comment things out, we're going to run over the 40-line limit that I had in my mind. But we'll say. Right. Okay. Here's what we'll do. Right. So under that, say struct node. No, it doesn't have to be in comments. So we'll, in fact, what we'll do struct, and lowercase s for struct node, and then say int data class int data, and then struct node star next. Okay, now let's put a comment on line 15 at the end of line 15 and say a struct in C++ is the same as a class in which everything is public. That's all. Okay, it is the same. And so, and now that we've done this, we can get rid of lines 9 to 13. We don't need this, right? We don't, because it is exactly the same. Is everybody on board so far? Okay, great. All right, now let's go to the public methods. Okay, public, say public. Colon, right? Now, what are the methods we want for the stack? So let's say we want to push an item on the stack, pop an item from the stack, peek in the stack to see what is the next item that if I pop, I'll pop, and peek. Yeah, I think let's do these 3 now. Oh, I will do is empty also. Okay, all right. So here are the methods we're going to write. So say first one, we'll say bool is empty, right? Is empty. And then open close parentheses. Now is empty is just a predicate method. It's a predicate. Predicate means it just says yes or no. And it's a predicate method is not going to touch the object. It's not going to change the object. So we'll just make double sure that anyone who implements is empty is not going to go and change the stack. Stick the word const after that. Great. Okay. Excellent. Right. So I put a semicolon after that. Right. So now that means that is empty is a method that returns true or false depending on whether the stack is empty. And that is something that we'll implement. So don't worry about it now. So another thing we want to do is let's say int top. Okay, top, int top. No, I say int peak. We want to peak in the. No, I will call it top. Okay, we'll call it. I'm sorry, Namrata. Okay, because it's top makes more sense for right. And again, that is also going to be const. And we'll put a comment on that line saying what element is on top of the stack, next in line for popping. Okay. Now let's say void pop. Okay, void pop. In fact, you make it bool pop. Okay, boolean pop, bool pop, bool pop, and then put a comment saying remove the top element. Return false if stack is empty. Okay, so next one we can, what is it? Push. Okay. So the next one should be should be void. Yeah, I think, no, yeah, it should be void because you're just pushing on. So void push, and then you're going to give it an integer. So int n, right? Int. Is that all we need? I think those are the only methods we need for the stack right now. So get rid of lines 19 and 20. Now go to the top, line 8, and hit enter. Line 8 and hit enter. Actually, you know what? Not line 8. Line 12 and hit enter. Right? And then one more. And say private, right? Private, a colon. And by the way, I don't know why online GDB is indenting it like this. Private and public, both private and public, take it and align it with the word class. Yeah. No, not all, everything. Just the word public and private. Yeah, right. Yeah, I think that's better. Oh, it did 4. And also that means push the struct node indentation also by 2 more. Yeah. No, 2 more on this side. Okay, all right. So yeah, the indentation needs to be fixed up, but you can do that later because data and node are not 4 now, it's only 2, but that's okay, right? So all right. So under private, you're going to say node star stack. And yeah, node star stack. We just call it stack, node star stack. Okay. Now under public, let's create a constructor. Okay, under public on line 17. So indent in and say stack underscore int, right? Open close, because it doesn't take any parameters. And then we can define the body in line. Right here, we can define the body of the method. So space, curly brace, and then you can say stack equals null, right? Stack equals, stack, yeah, equals null pointer. Meaning that when the stack is initialized, it doesn't have anything in it. It's a null pointer, empty stack. Yes? Yes or no? Is everybody okay with this so far? I should also at least get some feedback, okay? All right. Okay, let's do, I'm going to do line 19 and then we'll have questions again, okay? As I'll ask, is anything, so line 19 also, let's do inline, okay? Line 19, right? Yeah, inline, curly brace. And here, all you're going to do is return stack double equals null pointer. Okay, all right. So that is the semicolon. And you need a semicolon on the previous line too, on the constructor line. Okay. So stack int is your constructor, and it creates a stack, and then is empty. So as well, if the stack is empty, which means the variable, the member stack points to null pointer, then I'm going to return true. Otherwise, I'm going to return false. Yeah. Okay. So and that condition there is essentially what it is. So it takes a stack, compares it to null pointer. If it is a null pointer, that's going to be true. It'll return true. If it's not null pointer, it'll return false. Yes or no? So far, is everybody okay? Okay. So we've done those 2 methods. Now, because the stack is going to be on a heap, right? Because the stack is going to be on a heap, we also need a destructor for the stack. So let's go to line 18 and hit enter. Let's go to line 18 and hit enter and say tilde. Tilde is like this. Yeah, tilde, and say stack int. Open, close. Right now, put a semicolon because the tilde cannot. The destructor has got to do it's got to do a loop and all in there. So we won't do a destructor in inline like that. Okay. Now hit an enter after that. Hit an enter because in many good programs I've seen, what programmers do is they have the constructor and destructor, and a separate paragraph than other methods. Even other methods, sometimes they split it up, right? This bunch of methods deal with a screen, okay? Then a blank line. This bunch of methods deals with, you know, a database, blank method. So you separate it out into chunks. And the opening paragraph is the intro paragraph. And that is basically your, you know, constructor and destructor. They go there. Okay, so that's all of the things that we need. Now we can go out of line and implement those three methods, okay? Top, pop, and push. Okay, so let's implement, why don't we implement, which one do you want to implement first? Okay, how about this, okay? Which one do you guys want to implement first? We have three methods to implement. Oh, we have four. We also have to implement the destructor, okay? So which one do you want to implement first? Top?
Maybe go in order, I guess.
All right, okay, all right, as good as any. All right, so top, so let's implement top, and then curly brace, yeah, curly brace. Now, top just needs to return the element at the top. It doesn't need to do anything, yes? So what we're going to do here is, we'll do a ternary operator, okay? A ternary operator, if you don't want to use a ternary operator, you can use an if statement. That is also equally good. Ternary operator will just do the whole thing in one line, that's all, okay? So we're going to say return, and then within parentheses, say stack double equals null pointer question mark. Question mark, yeah, space. So if it is a null pointer, you're just going to return string double colon. Oh, you know what? Actually, yeah, return string colon double colon end pause, right? String double colon end pause. String. No. Oh, I see. We've never used it before. It's just a string, string, double colon, npos. Now, this is a special value. It is just an integer. String colon end pause is just an integer, right? It's not a fancy magic structure, just an integer. What is the value of that integer? That integer is the maximum possible value a long integer can have in C++. Okay, so essentially it is -1 in unsigned notation. Essentially, that's what it is. Okay, -1 in unsigned is 0 followed by -1 is 1 followed by all zeros, isn't it? In data representation, if you take a byte, what is -1 in 2's complement? It's 1 for the signed bit, and everything else is 0. That's your, yeah. But if you take that -1 and say it is not a signed number, it is an unsigned number, that means that it instantly becomes the biggest number possible. Well, it's not the biggest number possible, but it is a really big number. Yeah, it is. You know, if you go to -1, it is 1 all ones. Yeah, it is the biggest number possible, right? It's not 1 followed by all zeros. -1 in 2's complement is all ones. If you 0 minus 1 it becomes, you know, 1 is yeah, it's all ones. So in 2's complement, all ones is -1. But if it's not signed, you're going to say, well, it's an unsigned number. It is the biggest possible number. So string colon npos is actually the biggest possible number you can represent in C++. Why is that special? Why did they give it a special name and store it away in an include file, saying, well, you know what? The reason it's special is because sometimes you have a method that should return an integer, right? So let's say you have a substring method. You have a string and say, what is the index of character C in the string, right? So you guys scan the string and say, well, C occurs at position 51, so I'll return 51. C occurs at position 0, return 0, right? So it's got to return an integer. And so the method returns an unsigned integer because it doesn't make any sense to return a negative integer. So it returns an unsigned integer. But if it's going to return an unsigned integer, how can you indicate that the character does not even occur in the string? So, you know, so let's say, you know, Erica, so the name Erica, where is M in that, in Erica's name, right? So you can't say M occurs at index 0, you can't say because M does not occur in Erica's name at all. So you got to, but that method saying, find the letter, give me the index, has to return an integer. What can it return? So it can't return 0, and it can't return -1 because it's returning size T, yes? So you need to have some way of saying, well, you know what you're asking for? does not exist. So I'm going to return an error value, or I'm going to return a value that's illegal. So that is a way that the caller can make sure that the call failed. Otherwise, there's no way that the caller can tell that the call failed. If it returns a valid integer all the time, you can't tell the call failed. Yes. So in order for us to know that the call failed, it's got to return a special value that is not part of any legal value. Yes. Therefore, what programmers did was took all possible numbers that you can represent an integer, 4 billion numbers or something like that, and said, well, you know what? If you want to use a big number, you can use all of the numbers, but leave the last number alone. Don't touch that because we'll treat that as an illegal value. So the biggest number is treated as an illegal value. Exactly the same way as a null pointer is treated as an illegal pointer, right? The memory address 0, even though it's a valid memory address, it is treated as 0 because the system sets it apart, saying, well, null pointer is not for general purpose use. I'll use it for checking if it's a valid pointer or not. Same way, string colon n post is on the other side of a number. I said, that's a really big number, and let's make sure that it is never returned by any function, right? If it's returned by a function, that means that's an illegal number. So that is called, that goes by a special name, right? It's called a sentinel, right? It's an English word. A sentinel is basically something that gives you a signal, right? Railway tracks, that thing that goes up and down, right? Saying, oh, the track is clear and so on. That's called a sentinel. So a sentinel, no, that's not a sentinel. That's called a semaphore, right? A sentinel is basically a value that has been taken out of a bunch of legal values, taken out, saying that value, even though it is legal, it is not legal anymore because we're going to use it to signal something that's illegal. So that string colon n post is just a big number. And so in this case, we have a challenge with top because top is supposed to return the top element and it's returning an integer. But the top element could be anything. It could be a -1, it could be a +1. So how do you know? Well, how do you know that the stack is empty? If the stack is empty, how do you know when you call top that it's right? So that is why it says if it is a null pointer, it's going to return n post. If it is not, right? Colon is after string colon n post, say colon. No, inside. Yeah, right. So colon, and here you're going to say star stack. Okay, star stack, arrow. Oh, hang on, star stack. Yeah. Star stack, arrow data. All right, star. That's it. Okay, a semicolon at the end. In fact, what you can do is if we run over a line limit, like if we go over 50 lines, I think it'll be 50. Okay, then we can take this and make this function also an inline function because it's just one line. It's just one line. You can just turn that into an inline function inside of top. So, and by the way, you got to qualify the method top with stack int in front of it. Stack int : stack. Not there. Just before the word top. Okay. And we're going to put a comment on top of this method. So on top of this method, let's put it. Yeah, enter, and yeah. So top will return string colon n post. N position, right? Top will return n post if the stack is empty. Right? So on the next line, after that, you can also say, note this implies you cannot push string colon n post as a valid integer on the stack. You cannot use string colon n post as a valid stack entry. Yeah, you cannot use string colon n post as a valid stack entry. Yeah, you cannot use string colon n post as a valid stack entry. So we're basically sacrificing one of the values in the stack that could go on a stack and say, I'm never going to push this entry on the stack. If the stack is empty and I call a method that needs to return an integer, you can return this if the method goes wrong. That's all. Does this make sense? Is a very simple strategy, right? This is a very simple strategy of using what is called a sentinel to handle situations where you are forced to return a value, but you don't know what value to return. Yeah, you'll run across the situation many times in your life as a programmer. You'll write lots and lots of methods that have to return a value, but there is no way you can return a value in certain cases, right? In those cases, you have to discover a sentinel. Discovering sentinels or designing sentinels is not an easy task. Well, it's an easy task, but it's not trivial. Okay, it's not trivial because you got to look for of all of the data that I have, what part of which one of these data elements can I say is least likely to be used by users so I can take that away and make that illegal. right? So you take that, and that is called a sentinel. You say, I'm going to make a sentinel from the valid data. That's how you make it. Does that make sense to everybody? All right, great. Okay, well, Erica is the only one who said, give me a thumbs up, but we can come back to this later if you're not clear. Okay, so now let's implement the pop method. Okay, pop method into stack. Yeah, bool stack. Pop, yeah. And then here, let's copy line 30, line 30, and yeah, and put it there. Now here, what we're going to do is if the stack is empty, there's nothing to pop. Yes. So you can just say return false. If the stack is empty, you just return false. Not string or colon end post. You just say return false. Right? If the stack is not empty, however, you want to take the top element and throw it away. Essentially, throw it away. Yes. So what we can do there is how do we? I see. So all right. So we'll use an if statement. Okay. We'll use an if. We can do it in ternary with the ternary operator also, but it'll be ugly. Okay. It'll be ugly. So we'll do it using an if statement. Right. So yeah, there you go. If stack equals null pointer, yeah, curly brace. Then you say just return false. No, lowercase false. You know, is uppercase false a thing in Python? In some language, I think uppercase false is. Put a semicolon after that. Put a semicolon after that. You can get rid of that line. You can get rid of the top line, yeah. And put a semicolon after that, and get rid of the braces. You don't need braces because it's an early exit. Right now, we know the stack is not empty. All we need. This is very important. Okay. All we need to do now. The stack is not empty. So and the stack is basically a linked list of nodes, one after another. And the top node has got to disappear. So all we're going to do now is say node star p equals stack, node star p equals stack, semicolon. Right now, stack equals stack arrow next. And the next line, delete p. That's it. Okay, it's so simple, isn't it? So basically, you've got a chain of beads, and you're saying, and I said, you know, here's a chain. You got to give the chain back to me, but after removing the first bead. So what do? Right? If you remove the first bead, you don't have a handle to give the chain back to the caller. So what are you going to do? You're going to hold on to the second bead, right? And then pull off the first bead, and then return that to the user. Yes, that's what we're doing there. Okay, we held on to the stack. And then we say, well, you know what? We're going to go on to the next element because that's what I'm going to grab. Now the first element, now I can delete that. Okay, and I can return the first element. Yeah, right. So now we can return true. All right. So now the stack is now pointing to the second element. Is that clear? That's all. Okay, that's all you have to do for stack. You know, for pop. We'll do the push also. We'll do push. Okay, and I think push will be about 5 or 10 lines. Yeah, and then maybe we can, you know, so push will be, yeah, let's do void stack int double colon push int and yeah. So all this has to do is say node equals node star node p, right? Node star node p equals new node semicolon, and then say node arrow data equals n. Node p arrow data. Sorry, node p arrow. Right on the next line. Node p arrow next equals stack. Oh, no, hang on. Yeah, node p arrow next equals stack. Node p arrow next equals stack. And stack equals node p. It's a confusing set of lines, and I think this will take you a little bit of time to properly internalize. Don't give up, okay? If you don't understand these 3 lines, Don't give up, because this is like super duper important. And once you understand it, piece of cake, lots and lots of things will become very simple later on. But it's very important to understand this. Can everybody picture what's going on? That's we've implemented the whole stack right now, right? Oh no, we have to implement the destructor. We have to implement the destructor. Okay. Well, let's do the destructor too, and then we can clean it up and reduce lines and all sort of necessary. Let's do the destructor. Okay. So let's do the destructor. Stack double : tilde stack int, the stack int double : tilde stack int, right? And yeah, oh no, open close. Great. Okay. Now all this has to do is peel off the nodes one after another and delete them. That's all. So here you can simply do for p equals. No, let's do a while loop. Okay. So let's do a while loop. So yeah, say node star p equals stack. And what we can do is, oh, we'll write a version and then we can try and simplify it and make it more elegant and all. Okay. So while p is not equal to null pointer, what we want to do is say node star node to delete p, node to delete p, to a p pointer, yeah, equals p equals p. Next line, delete p equals p. Now what you can do is all right, p equals p arrow next. No, p equals p arrow next. No, arrow, not greater than. Okay. So and on the next line, you just want to say gee, you know what? Done this so many times, but hang on. So you got this, you got to delete this. And what you want to do is grab onto the node and then go to the next node, delete it, and then repeat it. You know, do that again and again until you get to null. So we got the node and it's not a null pointer. So what we're going to do, you should also be thinking, you know, thinking aloud, maybe not thinking aloud with me, but you should be thinking about this, okay? And feel free to correct it. You know, feel free to correct the code or say, oh, you know, this is what we should do. That is perfectly fine, okay? So I shouldn't be the only one doing this. So we've got this node. And also you can look at me, right? Because the way I'm thinking both verbally as well as gesturally. So you can think of, you can look at what's going on, right? So I've got the stack, which is basically a link of nodes. And I've said p, I've got a pointer that's pointing to the first node. And then as long as it's not a null pointer, I'm going to grab the next node and then delete this node and then set this node back to that. Okay. So node to delete. Yeah. So after line 54, hit enter after line 54. No. Yeah, you can do this. Well, let's do it after line 56 itself. Enter after line 56 and say delete node to delete. Delete node to delete. Yeah, right. That's basically it. And then you can delete the blank line after that. Let's run through this logic in our heads, okay? Let's run through this logic in our heads and make sure it works, okay? And all of you should run through this logic and you should let me know, hey, you know what? This is not going to work. Maybe there's a bug, because you know we're writing this dynamically on the fly here. I'm talking about code and Namrata is just typing, so we don't know if it's going to work because it's corner cases and so on. So think about it in your mind and say, hey, you know, is it going to check out or not? Okay, and after everybody's happy, we can go and clean up the code and make it, you know, fewer lines and if necessary. Okay, so does everybody understand what the destructor does? The destructor is given a chain. And all it does is go to the first element, okay, grab onto it. And as long as that element is not null, it is going to go to the next element, okay? And because that element P is the element that is going to be deleted. So before I delete it, I want to hold on to the next element. Because once I delete it, I won't be able to access this. Yes or no? Once I delete an element, I can access its next. So before I delete it, I want to grab onto its next. Now I can delete it. And then I make next the new first. And then repeat the process as long as P is not null, it'll clear off the entire stack. Yes or no? Is everybody clear so far? Now this piece of code, right? This and the push, that the pointer manipulation there is like super duper important, because you'll be doing this many times in quest number 9. Okay, quest 9, which is to do with linked lists and pointers and pointer manipulation. You got to take a node from there, stick it here. You got to take a node from here, stick it there, take that node and delete it. You got to insert a node in like 15th position in a list. All these things, you're going to be doing this in and out in your sleep, essentially. Okay, it has to become second nature, and the basis for all of that is just what we did, right? In these 15 lines of code here that you see in right, all it does is grab a node, just being super duper confident that your anything inside the node has to be grabbed before you delete the node. Biggest problem that many students have is that you delete the node and then try to get inside it, you'll get a error, because that once you delete it, it's been allocated to someone else, right? So and then you go and access it, the computer will kill you, right? So so it's important. So when you say I'm going to get rid of it, the first thing to do is before you get rid of it, take out the valuable parts, okay, and then get rid of it. And say, okay, now I'm going to repeat the same process down the line because everything has changed. Now this is an iterative delete procedure, right? Iterative memory release procedure, right? So we can put a comment. Yeah, put a comment at the end of line 51. Yeah, iterative, not recursive. It is better, right? Iterative, not recursive. Recursive, and then say within parentheses, it's better, better. Discuss in the forums, okay? Discuss. Yeah. All right. I think that is it. You can do we can do a once over of this code. Let's see. Can you scroll up a bit? We'll see if we can reduce the lines a few more. Yeah, let's take top and let's make top an inline method also, right? So take top and make that an inline method, and then we'll put a comment. Yeah, and then take that comment and take that comment. You can get rid of the comment that's already there on that line. You can get rid of the comment that's already there on that line, and instead, yeah. In fact, you know what? You can hit Control K and it'll delete everything to the end of that line. Type some junk and let's try see if that works. Type some junk and then go to the beginning of that line. Not the beginning. Yeah, there you go. Hit Control K. No, just Control K. Control K. It doesn't happen. No, nothing works. It doesn't. Oh wow. Okay. So online GDB doesn't recognize that. Okay, thank you for trying that experiment for me. Okay, now what we can do is that, yeah, you can get to that. And then what we'll do is take the comments on line 27 and 28. What we can put let's put it on top of line 22 maybe. Do we need the comment? Well, first of all, do we need the comment, right? Do we need the comment? We get, yeah, is the from the code that Stack is doing, can you guys, maybe not Namrata or Erica, someone else, read the code for top, that one line, and tell me if the comment is still necessary or it's not necessary because the code is clear enough, right? If the comment is not necessary, we'll just get rid of it. All right, it looks like the comment, some of you need the comment. So what we'll do is we'll leave the comment in there. And yeah, get rid of the blank line. So I'm trying to see how we can separate that out. Yeah, maybe put a new line there. And then after top also, after top, yeah. Okay, all right, maybe that is slightly better. Pop removes the top element. That's, pop, can we inline pop? What would pop? No, we can't inline pop. Oh, wait, let's see if we can inline pop. No pointer, otherwise, stack equals stack equals. Yeah, it's going to be messier to inline this because it's 3 lines and all. Get rid of the blank line on 41. Get rid of the blank line on 41. Yeah, and those blank lines also. Yeah, 41 and 32. All right, stack and push, and then, all right, we went to 54 lanes, but I think it could possibly be shortened somewhere here and there. And we'll leave the shortening as an exercise for you guys if you want to do it. But this is essentially it. It is a fully functional stack ADT. I think it is probably a first abstract data type too, but I don't think you've implemented an abstract data type before. In CS2A at least, this is the first abstract data type we implemented. It's a stack, meaning that it is capable of doing a lot of things, but it's only going to give you the functionality to do a couple of very simple things. Is empty, top, push, and pop. That's all you can do here. Okay, now you can test the stack out. You can test the stack out by doing in main. You can say, you can put a loop. How about I leave that as an exercise? It's very simple. So you're going to write a loop, a very simple loop. Let's say 10 minutes. Okay, 10 minutes for you guys. You're going to write a loop in which you prompt the user for a number. No. In fact, you should ask the user. Ask the user, do you want to push, pop, or examine the top of the stack? Okay, push, pop, or examine the top. And you can say, and the user will have to type POP, PUSH, or TOP, right? Or is empty too. You can do that, is empty. And then if it's pop, you're going to say, if the user is going to say pop, you just pop it and say pop return true or false. If it is empty, you're going to say is empty true or false. If it is push, you're going to say, what number do you want to push? And you ask the user for a number, get the number, and push that number. Okay. Oh, wait, you know what? Let's do one more method. Okay. Let's do one more method. Let's do a toString method. Okay. toString method. It's going to take us more than, it's going to go over the line limit. So go to line. Yeah. Go to the top and say, in your stack class. Yeah. There you go. String, toString, string, space, a toString method. Okay. And then this is also a const method. It's not going to change the stack, right? It's going to const method. Let's implement it. Let's implement it. So above main, you can say string, string stack int double colon toString. Yeah. All right. So here's what we'll do in our toString method. Let's do it in a very simple way. We'll just say, how about we just print all the, how about for our toString, we're just going to print all the numbers one after another. Is that okay? That's, simple enough. You can make this more interesting later on. You can say, number, arrow, number, arrow, number, arrow, and so on. You can do it any way you want. We'll just do one number per line, okay? So all we need to do here is we need a for loop, which goes through the stack and prints the number, data element, data, new line, data, new line, data, new, until you go to a null pointer, which is the last one. Yeah. So that's all you're going to do. 3 lines of code, maybe 2 lines of code. Actually, it's only 2 lines of code because you got a for. You don't even need braces for, and then your cout statement. 2 lines. Do you guys want to do the two-line toString method on your own? I think you should, because there's no pointer manipulation here. You're just skipping these things and printing these out. So how about I give you 5 minutes to implement the toString method, and then 10 minutes to implement your main after that, okay? So first do the toString method and then call me, right? After doing the toString method, 5 minutes, call me. We'll take a review of the toString method, say it's okay. And after that, you can do the main. You'll get 10 minutes to do the main, okay? And after that's done, we can come back. We'll do another exercise with linked lists. And say, well, we'll now create 2 linked lists and try and merge them together, okay? What time is it now? It's probably on, it's 9:10. So we have a lot of time. Most probably we'll be done with the stack by 9:20 or so. We'll have a lot of time to do linked lists and merging linked lists after that. Okay, so that's all I have today. Say for a stack data type. You won't be implementing this kind of stack in Quest 8. In Quest 8, you're going to be implementing a stack using an array. It's actually easier in many ways. So that's what you'll be doing. And so this is the other way of implementing a stack. Okay, so can you guys do the toString method? Now, Namrata should not type. No, Namrata will type, but she won't code, okay? Namrata, you're not going to code, okay? Someone else is going to call the code. So anyone else can call out the code, even multiple people. Multiple people can call out the code, especially, Matt, Sabrina, Hannah, Elijah, right? So Simon, you guys should call out the code, and then Namrata will type it in, okay? 5 minutes. And I'll be back in 5 minutes. Just turn the laptop around. I'm going to be here, okay? Just going to be not in your face. So 5 minutes, and I'll check back in. So it won't even take you 5 minutes, I think, right? It'll probably take you 2 minutes, but to be on the safe side. Okay? So, hey, Google, start a timer for 5 minutes. Hey, Google, start a timer for 5 minutes. Oh, not on my phone. All right, okay, on my phone.
All right, 5 minutes, starting now.
That's funny. Hey, that's really cool. You hear that? So it started the timer on my phone. When I said, start a timer for 5 minutes, and I said, oh, no, not on my phone. And then my Google Nest picked up from there. Or maybe it picked up in the beginning and said, all right, 5 minutes on my Google Nest now. Let's see what happens.
Anybody want to start and help Namrata? Even though I know she probably knows what to do.
So would we do something with the while loop similar to what the destructor was doing?
I think, did he say to use a 4?
Oh, use a for loop?
Use
Yeah.
any loop. And also remember that string.append method will add things to the end of a string. So you can start with an empty string, keep adding to the end, and return the whole string at the end. So you can use any loop you want.
Okay.
And don't worry about the 2-line limit, okay? So if it takes more lines, it takes more lines.
Okay, what you have okay.
Okay, so we should probably make like a string something, string line or string something. Call it, yeah. Yeah, and then for size t of I equals 0. Yeah, I is less than a line dot length, I think, right? I don't know. Correct me if I'm wrong, guys.
Well, would we do like we're adding into like the line, right? So we have to like go through the stack.
Yeah, I'm not super great. Like I'm still kind of processing stack, so I didn't really pick up until right now. Yeah, this is as far as I was like an I++. But yeah, because you're like adding lines and it's not the length of the string. Or would it be the I doesn't equal null pointer? Like yeah, it's not as long as it's not empty, I think.
Yeah. We'll just have to change the type, but yeah, I think that's what it's supposed to be. So this be
Oh yeah, I didn't even, yep.
and then What will we set it equal to at the first?
Yeah, the first node.
Like that?
Hey, Google, stop the timer. Stop.
I think so. So wouldn't we do, yeah, like, yeah, the node star I equals for like the 4. Would it be stack?
I was just looking at like this one, kind of.
Okay, and then yeah. That's what I was gonna say too. Then you already put it in. Ooh.
So what would we use to like add to the lines?
I think the professor mentioned the append to like append it to whatever we have, right?
And you just like
Like I've always used like string to just kind of push it onto stuff. But
could you just use like the plus or
Yeah, plus should work. Plus will also work for strings. It's the same as append.
maybe something like that?
yeah, I think so. Yeah. Right. Oh wait. We didn't already. Didn't we already assign I as? Can we? Yeah, I think
We'll
so.
just,
Yeah, you're right. You're right.
yeah.
Yeah,
Like
that's
I get the data of I and then it puts it in like I think.
yeah. No, I think you're right. I was just processing.
And then we have to add a new line after, right?
Yes.
That all we have to do?
I think so.
Hmm.
Mm. Yeah. I feel like this checks out.
So now we have to do like this loop, right?
Oh, yeah. No, yeah, we didn't do that yet. Yeah, I guess I'll write the first like see out message about asking if they want to push, pop, or I forgot what the last question to the user was supposed to be.
If they're pushing, do we want them to like type push and then like the number or just the number?
Probably just the number, right? Because then for the other ones, they could do pop or type in empty.
I think it'll be easier if you first in the loop that Namrata is typing right now, just ask them to type one of 4 words. Push, pop is empty, so you just need to check for those 4 words. Type push, pop, top, or is empty, or 2 string 5, right? You can also do 2 string and then inside of the each condition you can have a separate loop or whatever it is, right? So prompt the user. If it's a push, you can say in there, you can say prompt the user and get the number, push it. Yeah. And you need a colon, and then a space for the user because it's a prompt, isn't it? And you don't need the colon go after the word type. And I also have a stylistic suggestion for line for the previous method you wrote. When you have a pointer, try not to use I, J, K, etc. to as pointer variables, because for most programmers, mathematicians, I, J, K are integers, and they can be, yeah, exactly. Also, same reason why I also discourage students from using X, Y, Z for integers. For mathematicians, X, Y, Z are not integers; they are real valued numbers. Yes, is the X axis. So just to keep the nomenclature similar to what most people are used to will be better. Yeah. So that's good. Yeah, line 69. You can, and then you can do a CN and get the value, or get line and get the value. Get line. Actually, you have to do get line because 2 string is 2 words, right? And it's not 1 word. Yeah. Now you can compare input, and you can put blank line after line 67 too, so that the declaration part is separate from the loop. So you can say, now you can say if input equals double equals push, and you can do curly braces. You can come back to this later. Flesh out the rest, right? Yeah. Now else if you can say else if, and the else if can go on the same line. Yeah, exactly. Else if input equals pop. And curly brace.
Is this a type of situation where you could use like the switch?
You can, no, not in this case, because good question. Because if you are just comparing to integers, then you can totally use a switch statement. Unfortunately, switch will not work for non-integral data types. So you're comparing to a string, you cannot use a switch statement. Good question, Namrata. So you can, oh, and toString. Right, now let's do the easy ones first. The easy ones are just one line, most of them, right? The easy ones are just one line. So push is probably the harder one because you got to ask the user and all. Everything else, you don't have to ask the user. So you can just say, for that, you can just say, oh, where is your stack? Oh, you got to declare a stack. Yeah, you got to declare a stack, my stack, right? Call it a stack int my stack. I think you called it my stack int, right? My stack. No, you can just say, no, the stack doesn't need to be on heap, right? This is a stack. The stack itself does not need to be on heap. The stack, the class, the object, the actual stack inside of that, that's what is on the heap. This wrapper class is not on the heap. Okay, so now you can say, oh, and join up line 69 with it too, because that's the declaration. Okay, and then here for leave push alone for now, you can come back to push. And also, let's do one more clean thing here. On line 72, where you have get line, say if get line, put an if in front of the get line, right? Open parentheses. If open parentheses after the word if, before G, right? Now put a vertical bar and an exclamation mark. If not get line, right? And get rid of the curly braces, and just say continue. Meaning that if there is no input, you're just going to go back and ask, print the prompt again. So only if there's input, you go on to the next lines. If there's no input, you just go back to the top. Does that make sense to everybody? So now let's do push at the end because it's harder because it needs to ask for user input. Pop is really easy. All you need to do is just say, C out. So C out, left shift, and say pop returned. Within quotes, you say pop, open close. Yeah, pop returned space. All right. So space after that. Right, and then left shift again. Yeah, cool, thank you. Right, left shift, and you just say my stack.pop, and then end line. Everybody clear so far? That's all. And then end line, and end out, right? That's it, right? Now you can do the same thing for top, and you get rid of the blank line after that. For top, you're going to do pretty much the same thing. Yeah, in fact, it is the same thing because if the stack was empty, it is going to return that big number one, big number -1. Okay, is empty. Oh, is empty is also the same. You get exactly the same in all of these cases. Now toString will probably produce something different. Okay, so we need the same thing. Yeah, so you say cout toString return. Now after, you did do toString there. However, toString is going to return a bunch of lines. You want a new line before and after, right? So put a new line before also. In fact, yeah, after return you put a /n. After return you put a /n. Yeah, there you go. And get rid of the space before the /n because it's not visible. Yeah. Okay, now push is the only thing that needs to be done. And for push, all you're going to do is print another prompt asking the user to enter a number, and then you're going to push it. That's all. No, you can't. Get line only gets a string. So you have to get it into input. No, get line cin and then input, not number, input. Now you can use iString stream to convert input into a number. So you say iString stream, ISS. Is it iString stream or O-string stream, is it? No, iString stream, iString stream. Space, ISS. In fact, you don't even need that, right? What you can do is iString stream, parentheses, input. Input can be within parentheses, iString stream. No, not there. For iString stream. iString stream, you can parameterize iString stream. Not there, no. iString stream, this is a new, you haven't done this before, so I'll explain it, okay? So iString stream, no ISS there. Instead of ISS, just say open parentheses, input in there, right? Now, outside of the parentheses, say right shift into number. That's it, okay? Now get rid of the space before the open parentheses because, input is, right? So iString stream is a constructor for the string stream class. It's going to create an object. This is a string stream, which is similar to CN, behaves similar to CN. And it needs a parameter to make the constructor, yes? The string stream needs a string for a parameter. You give it the string. You say, here's the input, make a stream from it. It's going to return a stream. You're going to, and then usually what we do is we name the string and then read from it. But here you're just going to read one thing from it. So you say, I'm not even going to name it. I'll just use an anonymous iString. So you say, get it and then read from it. That's it, you're done. So it's an anonymous call right there. So this is also a very useful construct to have in your mind, saying that when you want to create an object and you really don't need to name the object because you're only going to use it one time. So you don't have to name the object. Is it possible in other languages? Maybe it's possible in other languages too. But this is a very nice way to do it because many times you want to use an object which will do a lot of job in the lot of the work in the constructor, but you don't have any use for the object after it's been constructed. So you just do it one time there, and don't name it, and just use it like that, like this. Okay. So now you have the number. You can say, my stack.push number. That is it, actually. I think, yeah, semicolon. How many lines is it altogether? Altogether, it's under 100 lines. Get rid of the line 90. Get rid of line 90 because you don't need that. Yeah, it's under 100 lines, including your test driver. If you run it now, you should be able to run it. Oh, you got 2 blank lines after continue. Yeah. Okay, so if you run it now, I think you need an iString stream. You need to include S-stream at the top, S-stream. Include S-stream. Yeah, I think there are no errors as far as I can tell. If you run it now, we'll see, Yeah, so there are errors. What does it say? Invalid return of unary.
That's funny because I'm copying this in Xcode and I'm getting the same errors.
You are getting the same errors in Xcode also?
Yeah.
Okay. All right. So here's what you can do. You see that star stack arrow data. Put that inside of parentheses of its own. No, wait a second. No, wait a second. Returns and question. Yeah, that looks all right to me. Arrow data. Yeah, put that in parentheses of its own. Stack arrow data, put that in parentheses of its own. In line 26, Oh, you did it already. I'm looking at it. I'm looking at the compiler output. Run it now. We'll see if we get the same error. You still have it. Okay, so invalid type of argument, unary star. Yeah. All right. Not star stack arrow data. Is this stack arrow data? See, stack is not a pointer. Stack arrow next is a pointer. Stack itself is not a pointer. Yes? All right. So only Erica is nodding. Because this was a bug and it's a very helpful bug, okay? Because it helps us. Stack is not a pointer because it helps us in understanding something. Stack is not a pointer. It contains an object called stack that's a pointer, but my stack is not a pointer. My stack is just a stack object. Yes? My stack is a wrapper, is a container, it's a box. It is not a pointer. Inside the box, there is a pointer called stack. Yes or no?
Yes. So would you advise not naming the wrapper the same as?
No. You just have to get rid of. You have to get rid of the star in front of stack. Where you have further down. Where you have that. Where is that? Yeah, a stack arrow data. Yeah, I think that's all you need, right? Because you don't need. If you compile it now, that error will go away because you know. Oh no, wait a sec. Wait a sec. Let's fix this, okay? And then I want to come back to this and. Oh, stack arrow next. I think instead of stack arrow next, you're saying stack arrow node P somewhere. Line 47. Oh, wait a sec. Oh, something is funky here. Yeah. Stack equals stack arrow next. Oh no, wait, no, that's not true either. What did we do here? Right, create a new node, put the data in the node, and then my stack. Oh, stack equals node P, not stack arrow node P. Stack equals node P. Okay, run it now. All right. Oh, wait a sec. You got an extra curly brace or something there. Line 64. Let's check line 64. Oh, yeah. You have the for. The for loop. For loop has two statements but no curly braces. The for loop has two statements but no curly braces. Yeah. Now let's take a look at that other thing with the star stack. I want to make sure that everybody's on the same page before we run it. Right. Did everybody understand what we did there? Our stack is basically that node star. The stack inside the push method is that node pointer. Yeah. So we can say stack arrow data because stack is a node pointer. Pointer arrow data is going to get the data from that node. Yes or no?
Wait, hold on.
Yeah. Take your time, okay? In fact, we don't have to do the other part. We can still do the linked list part on Thursday, okay? Don't worry about it. We can do the rest of this class can just be on understanding this because there's a lot of subtle nuances here, and it's important to spend time and say, hey, I don't understand this exactly what Erica did. You need to get to the bottom of this, and then everything will be hunky dory after that, okay? So, what's going on there is that if you look at the stack class, inside of the stack class, our stack is basically called stack int, okay? Maybe I'll say stack int, okay? Inside of our stack int, which is a box, there is a pointer called stack. Yes or no? Everybody on the same page, okay? Not just Erica because she asked a question. Everybody needs to say yes or no, right? Simon, Karthik, are you all on the same page? Hannah, Sabrina, Matt, Elijah? So you have this class, this object called stack int. We created an object called stack int, okay? And that stack int is not on the heap. It's not, it's not in dynamic. The stack int is right here. It's not a pointer. Stack int is not a pointer. It's an actual object. But inside of my stack int, there is this node star stack, which is a pointer. Yes or no? Simon? Yes? Okay, so inside of my stack int, I have a pointer. So my stack is not a pointer, but my stack int is not a pointer. Inside of that, I have a pointer for a node. Okay, great. So in my top method, okay, stack points to that pointer, right? So it's not stack int, it is stack pointer. So I need to get the top element, which is basically the data element of the very top element. So the top element is being pointed to by stack. Okay, and you're getting the top element, the data out of that. In fact, what would be really, really helpful for you later on, if you still don't understand this, is to just draw it out on a piece of paper, okay? It won't take you a lot of time. Draw it out on a piece of paper. All we need, and I bet 99% of the confusion, if you are confused, if any of you are confused, 99% of the confusion is just to do with, in our minds, distinguishing between what is stack int and what is stack, right? Because unfortunately, we're using the same name. Why don't we do something which is clearer? Okay, we'll do something clearer. Is it possible for you to rename all of the node star, the internal member stack? Just call it node, lowercase node. Okay, no, node P. Call it node P. Oh, no, okay. If you do it, does it do it everywhere? If it doesn't do it everywhere, then it's going to be a problem because it'll cause errors, and don't do it unless we're confident it'll do it. Don't do it. But in your mind, you can do it. Okay. That is just a node pointer. That's that thing, that variable that you have there is just a node pointer, and it lives inside the stack int class. Okay. A stack int object has a node pointer inside of it called stack. When we want the top element, we're going to go inside that node and pull the data element out and give it to the caller. And that's what we're doing there. Stack arrow data. So if you called it node P, it'll be node P arrow data. Or in fact, you know, what we should do is that stack should basically be called top node. Okay. Yeah, I think that'll be a whole lot easier for students. Okay, especially since you're going to be saving it and sharing it and all. Change that. Change line 16. Change stack to top node. Top node. And then line 19. Top node. Yeah, top node. Top node. That one also. Yeah. It's in top node arrow data. Top node arrow data. Okay. Push. And then methods, in the methods. Top node arrow next. Yeah. Top node equals node P. Yeah, I think that's Namrata got all of it, I think. So if you compile and run it now, let's see if we clear. Yeah, okay, right. So it did work. However, you know, just the fact that it works should not be a cause for us to celebrate, because we don't know if it's going to do the right thing or not. Okay, so all right, so you can try and you can test it out now. So just do a toString, it should say nothing, right? toString should say nothing. Nothing. Yeah. Now let's push something and then do a toString again. Oh, all right, kill it. You need to print a prompt. Okay, kill it, right? So in your push method, you got to see out a prompt. Okay, see out what number do you want to push, right? Yeah, type a number. Yeah, whatever you wanted. Type a number to push. You know, you said type a number to push on the stack. Okay, so I think yeah, that should be fine. If you run it now. And push a number on the stack and then do a toString. Hey, you're getting a blank. Push a couple more numbers and then we'll go back and look at it, okay? Push one more number. So there's a bug there. There's a bug there. I bet we can fix it, okay? Yeah, toString here. Okay, so something is funky. Let's take a look at your toString method. And do you want me to debug it, or you guys want to take a stab at debugging it yourself? Okay, all right. So here is what is going on, and I think what's going on is that the string class is not allowing you to add a number to a string. You can add two strings together, but if you add a number to a string, I think the string class is misbehaving. So we can test it out very easily. All you have to do is really on line 60, hit on line 60.
Use a pen.
Yeah, it's a string stream. We'll just use a string stream. So on line 60, just say O string stream, O string stream, OS, O string stream, OS. And then within parentheses say empty string. Within parentheses you just say empty string. no, double quotes. Yeah, and then get rid of everything else, a semicolon at the end, and a blank line after that. Now, where you say lines plus equals p arrow data, you just say OS left shift p arrow data. Yeah, and then you can left shift p arrow data, left shift new line right there. You can do it all in one line. Right? And then you don't need curly braces for the for anymore because it's just one line, right? Now, where you have return lines, you just say return os.str. That's it, okay? That's an easier way to concatenate strings. You just create a stream and you keep sending stuff to it, and the operator understands how to take numbers, convert it to a string, and put it there. And so the operator will take care. Everything is done. When everything is done, the stream is full. You can say, get me the string out of it. So that is your os.str. If you run it now, I bet you'll get the string. Okay. So yeah, push one number, push a single number, and then do a toString, and let's see if we get it. There you go. Okay. So you can push more numbers, and then push more numbers, and you can pop more, right? Push more, but yeah, push. Now toString, and you should see 3 numbers, right? Now if you pop, what will go? 1 is not going to go, 3 will go, right? If you pop, 3 will go. See, pop returned 1. So here, okay, so it returns true or false, and however, it's saying pop returned 1. And that is a problem. No, not a problem with our code. It is a slight issue with C++ itself. It's the only thing I can think of that is an issue with C++ is that it is treating, because it inherited from the C language, 0 and non-zero values as synonyms for true and false, or false and true. So it got true, which is 1, and saying, oh, it returned true, and it's printing 1. Technically, it should print, true or false, and it's not doing that. But we have to understand that. Okay. So all right. So you can continue to pop until the stack is empty, and then do an isEmpty call, right? You can do an isEmpty call. It should say false. I think it's 1 word, isn't it? Oh, it is 2 words. You did do 2 words for isEmpty? Yeah, okay, cool. isEmpty returned 0, which means it's false, okay? And you can keep popping 2 more times and then do an isEmpty call. We'll see if it gets true. You can do pop 1 more time, and you should get false this time, right? You do pop. There you go, right? It's false now because it was empty. There's nothing to pop. Now, if you do a toString, you'll get an empty stack. Yeah, isEmpty will return true. isEmpty will return true. Yeah, 1 is true. Now, if you're confused, if the 1 and 0 and 1 confusing, we can fix that easily. Okay, so go back to your code. Go back to your code where you say. Where do you print the value in your main, top returned, right? Pop returned, right? Okay. So here's what you can do to make it more readable. You can say, convert to yes or no, convert to TF, convert to YN, right? Or convert to TF. So say convert to TF, convert to true false, right? True false. Yeah, all right. So and then close the thing after my pop there. Okay. And then you need the same thing for top also. And need the same thing for top as well as for my stack.toEmpty. Right now, let's define the method right above main. It's a utility method. Yeah, one more. We say string convert to TF, and then it takes a parameter, parameter bool, right? Bool p proposition, right? Bool p, right? And then curly brace enter, and we'll do a ternary operator here. Okay, so return p question mark. Right? If it is true, we just want to say true. It returns true, right? If it's false, you just want to say false. That's all. Yeah, semicolon and space before that. Yeah, there you go. Thank you. Right, that's all. Now, if you run it now, you'll get the words true or false instead of 0 and 1, which is easier. Yeah. You can do toString. You can do isEmpty. You should, and isEmpty should say true, because it's right. So that is it, right? I told you this class is going to be like super duper simple. That is your stack class. And although the code for the stack is very minimal here, it's only like less than 100 lines. Yeah. I think that it has a few subtleties and nuances that are super duper important. So if you agree that if that's the case, it behooves a lot of time from you to just go over the code many times. Make sure you understand everything. Okay, every single little thing here. It is easy. I can tell you, I guarantee everything in this code is actually easy. It looks complicated because of arrows and new things like star and things like that, but it's actually deadly easy. The only people who find it hard are the people who falsely believe it is hard, right? So if you give someone this thing and say, well, it's a hard thing because it has pointers in it, you got to understand it, they'll take several days to understand it, okay? Do a psychology experiment. Give it to someone else. 2 people, right? And the other person, tell them it's actually easy, right? It's very easy. This is just a few syntactical things that you need to understand. It's just a different language. Star means contents of, and so on and so forth. That person will understand it within a couple of hours. So you just need to believe it is easy, just like in real life, okay? Believe it is easy, it'll be easy. Believe it is hard, it's going to be hard. Because if you think it is hard, you don't want to be saying, well, you know what? I thought it was hard. I was a fool to think that it was hard. It's actually easy. I was a fool. Nobody in their life, in their right minds, want to believe they're a fool. Even if it's going to make their lives easier, they don't want to believe they're a fool. Or I was a fool that time. That's why. So they'll say, no, it is hard. There must be a reason why it's hard. Let me try and find a reason why it's hard. They'll somehow find a reason that's hard. Same, right? When you interact with people too, when you're interacting with someone, it's a new person you've never met before in their life. But if you have someone else tell you that person is a really nasty person, okay? Even before you meet them and your mind is made up, chances are very, very high that after the meeting, you're going to say, yes, that person was a nasty person because I noticed them doing these things that a nice person wouldn't have done. Okay, that's because your mind was already primed. This is, just like pattern recognition in computer science. The prior probability is a huge determining factor. It's called the prior. If you've done statistics, the posterior probability is the prior probability times. Yes, so the prior probability is 0. It'll never get recognized. If the prior probability is high, there's a very high chance of false recognition. So when we say, that person is bad, you're automatically already your mind is decided, and it's going to find all the bad things about that person. That is why it is easier to find bad things about other people than finding good things about other people. Because everybody has a lot of good things. People don't look for the good things. They look for the bad things because they say, I'm not a fool. I was not a fool to say I was wrong. So let me, that is hard. So I'm going to try and find out why it is hard. No, it is not hard. Believe it is easy. Believe that things out there are easy. Believe that things out there are within your reach. You can go and do these things. Everything out there you can do. Right? So people who don't do things are basically just people who settle and say, I'm not going to do this because it's beyond me. And there's no reason for you to believe that. Believe that you can do it, and you can do it. Okay? It's just a question of time. And people who believe that they can do it will spend time and not worry about, oh, it's painful and so on, because they believe they can do it. They can see the finished product. So the pain is not even visible to them, right? They'll just keep persevering and say, well, I'm persevering. I know I'm going to do that. I'm going to keep practicing more and more until I get there. They'll do it without pain, right? Whereas people who say it's going to be hard, they'll still do it, but it'll be painful for them. Saying, oh, I don't know if I'm going to succeed because, it may be hard. So I'm still going to do it. And this was they put a half-hearted effort because they don't know if it's going to succeed. That means they have their have bets hedged. They have other things they're working on in case this fails, right? So already you're not putting 100% into it because you think it's going to fail. You're working on other things, other courses, other things will take up your time. So you're spending less time. So that also militates against your success. So once you believe something is hard or believe someone is bad, then the odds are hugely stacked in your favor of finding out what you believed was actually true, even though it may not be true. So that is, I think, the lesson that the Stack class teaches us today is to just believe that it is easy. It is easy, okay? Ask questions in the forum. There are so many people who can help. I can help. Tutors can help. Your classmates can help. But get this solid, and then your quest number 8, and also all of 2B. will be super duper easy, okay? Because in 2B, you're going to be doing lots and lots of pointer manipulations, And when you're talking about the advanced problems, you cannot afford to think about the lower level solutions, okay? People who think about the lower, I need to understand that, I need to understand this before I understand that, they'll be floundering out there. And floundering means that's a signal to fellow teammates saying, well, you know what, let's get this done, and that person catch up. Never happens, okay? That person usually doesn't catch up and drop off and they get out of the team eventually. So don't let that happen to you. So just stay on top and saying, you know, this is going to be easy because I'm going to go in prepared. If you go in prepared, it's going to be easy. If you don't go in prepared, it's going to be hard. So get solid on this, and you'll find that 2B is a piece of cake. 2C, you know, is again, once you have this already, 2C is largely about solving things that you would have solved anyway in your life, right? Because many of the problems we encounter in 2C higher level problems. They're problems we do, solve in everyday life. We're just trying to see, well, can we solve this slightly more easily, right? Can we solve with less effort and so on. And so bringing our everyday thinking to bear on problems is what 2C is. But people find 2C hard if in the process of trying to come up with everyday solutions, they're also having to try and master lower level stuff. And that is not a good combination. You need to get this out of your way before you think about the hard problems. And thinking about both, you'll never master both. And so that is the ticket, I think. So stay on this as much as you can. Get really, really solid on pointer manipulation. Stacks are I think the safest way to play with pointers. This is very simple, easy to understand, small code. And also there's no splicing in stacks, okay? So you don't get given a node and saying, well, this needs to go on the stack, but in the 15th place. Nobody ever does it to a stack, right? You can do it to a list. List, you can say, well, it needs to go in the 15th element, but you can't do it to a stack. So stack is actually very simple. And so it's a useful data structure to get the hang of. And you'll find that everything is easy once you master the pointer manipulation in stacks, not the array-based stacks, pointer manipulation in stacks. And again, I hope to see you all in 2B, because I don't know, even though many of you are enrolled in my 2B, I hope the class runs and doesn't get canceled for lack of enrollment. So please encourage your classmates, especially at UCs, right? I'm pretty sure at UCs, there are lots of your classmates, Namrata, who may benefit from, a course in 2B, pointer manipulation. Even if they're doing some similar courses or next level courses at UCSC, the knowledge you get in 2B will make you perform better in your UCSC courses downstream, because you'll learn some very useful skills. So you can pass the message along and say, hey, do it. Let's all do this together, because there'll be a contingent of UC students in our class, and they can work together too, because they'll be, in the dorms, they can get together and have fun. So that will also work in your favor. But otherwise, if you don't manage to get in and you want to wait until summer, in summer, if this class is canceled, I'm offering 2B again in summer. Hopefully that will have enough enrollment, because usually in summer, lots of high schoolers get into 2B. And so that usually fills up very quickly. But summer 2B is, I don't know. I personally wouldn't do it, because it's like saying, here's a Baskin Robbins ice cream store. You need to get in. You got 2 minutes. You got to go in and taste everything and come out in 2 minutes, right? This is no fun. Yeah, and you come out and say, hey, what was the cotton candy flavor like? They wouldn't remember, right? So because that'd be blueberry, cotton, strawberry, tasted everything and come out, you don't remember anything. And you wouldn't have understood much of what's going on either. So 2B, unless you're crazy about, getting qualifications and tucking them under your belt, you shouldn't really do 2B and 2C in summer. Okay, 2A is okay, because 2A, you can do it in summer, provided you have enough time. 2B, you need to be more prepared to do in summer. So, but if you don't do 2B in summer, you can still do it in fall of next quarter. Okay, I'm still around next quarter, next fall. After summer, I'll be in teaching 2B. You can do it then. Hopefully that won't get canceled. But in the fall, I think has decent enrollment in 2B. Winter this time. No, spring. But I think we're good. Did you guys learn useful stuff today? Was stuff that you did today useful? Yeah. Okay, great. Do you have any questions at all? Erica, you look like you have a question.
Oh, I was just gonna ask Namrata. You're gonna post the class code at some. Yeah. Okay. Cool.
Yeah. Numbers I usually post it. And
probably have questions on Thursday.
Yeah. Go ahead. You'll have questions on Thursday. Yeah. Absolutely. I look forward to those questions.
Catch up better.
Yeah, and in fact, after answering questions, we can do the linked lists, the 2 linked lists, and braiding the 2 linked lists together. That will be a fun project to do on Tuesday. And next week we can try and do some entertaining with linked lists. Okay. All right. Thank you all for tuning up to these classes. As you know, right? If people are not there, there's no fun at all. Luckily, you guys are here today, but if there was only 1 or 2 students, I could just do a one-on-one or one-on-two with them, and they may also feel right. Well, it's not much fun if just the 2 of us, right? So it's better to get lots of people, and have a proper party. This is like a CS2A party, right? Lots and lots of people should come. Okay, all right, thank you. I don't have anything else to say, unless you guys have anything to say. I will just call it a day. And I look forward to seeing you all on Thursday, okay? Bye.